2 plasma accelerator, QSPA, Higgs Particle, Quasi-Steady-State fusion, Atlas file lines 10A, 18A, 22E. I had to break it up into 2 videos because I ran out of battery power, so the other one starts with a 1, okay? So this is a continuation of that video, so you want to backtrack to it. Just type in a 1 instead of a 2, okay? So we're going back to the, we're doing the formulas from, what do we got here? From this video here, we're cross-referencing line 22E, 10A, neutron, triton, binding energy, lithium-7 scattering, 5G well study. So it's from the WOW data with the Higgs boson signal stuff. So I'm going to just go eliminating the overlapping of scattered thermal neutrons components from the objects in ETRR, 2 neutron radiography facility using aluminum GD coded anti-scatter grid, plus the MCNP code, plus optimum grid dimensions that will reduce the scattered thermal neutrons from the object. We're going to add optimum grid height and irradiation time, plus best image, plus geometric sharpness, plus NCNP code, plus scattered neutrons were removed by the grid, plus ratio of neutron over proton matrix elements by inelastic proton scattering, plus transitions, plus wide mass range nuclei, plus neutron over proton matrix elements ratios, plus neutron over proton matrix elements by inelastic proton scattering, plus transitions. So I'm going to add the prompt fission neutron spectrum measurements, plus neutron detector, plus neutron energy range of 100 keV to 20 MeV, plus energy is greater than 5.0 MeV. Add the weapons neutron research, WNR, plus the white neutron source, plus pulse beam, plus time of flight, TOF, plus carbon, plus polyethylene, plus graphite scatterers, plus hydrogen spectrum, plus HNN scattering cross-section, plus SINFO, plus radiation shielding information center. We're going to add the neutron scattering, plus acinide region, plus fission, neutron energy spectra, plus neutron detector, plus the neutron scattering, plus inelastic neutron scattering, plus inelastic scattering, plus neutron-induced effects in silicon dioxide MOS structures. Nucleon momentum distributions of 39K, 40Ca, 48Ca, plus proton momentum distributions, plus electron elastic scattering, plus muonic atoms, plus flucton model, plus momentum distribution, plus charge distribution, plus neutron distributions using the single particle potential method, plus differences between the proton and neutron momentum distributions, plus momentum distribution in the case of 40Ca, plus analyzing the quasi-elastic electron scattering, plus crystal field splitting of the 3H4 ground state, plus prion, plus PRFeO3, plus PRGaO3, plus inelastic scattering, plus thermal neutrons, plus several temperatures, plus transitions, plus TAS, plus TOF methods for polycrystalline PREF3EO, plus TOF method for polycrystalline pre-JO3, plus energy level, plus crystal field and Prenal, those words there, intermetallic compounds, plus inelastic neutron spectroscopy, compounds crystallized, plus ZRNIAL type hexagonal structure, plus orthohommic symmetry, plus specific heat data, plus lower parts, plus crystal field energy level. So I'm going to Google Skinful to see what it means, and Google Radiation Shielding Information Center. I'll do the Google searches in line 22E, 10B. That was another video, so I guess I don't do it in this one. I did it in that one instead. So small angle neutron scattering is SANSA plus unilamellar vesicle populations under 500 and 1000 angstrom plus lipid vesicles plus whatever that word means, plus 3 phases, gel, ripple, and liquid, plus internal structure, plus DMPC bilayer, plus separated form factor SFF model, plus parameters of the internal bilayer structure. These are all keywords, by the way. Thickness of the membrane and the core hydration and surface area of the lipid molecule, plus hydrophobic hydrophilic HH, plus neutron scattering length density, across the bar layer Rx and of the step function SF approximation of Rx, plus HH plus DMPC membrane thickness in liquid phase, T equals 30 degrees plus membrane curvature, plus neutron scattering plus mixed valence MV compounds SMB a sub 6, plus inelastic magnetic response of SMB sub 6 at T equals 2K plus double isotope single crystal, plus peak at 35 MeV plus inter multiplet transition of SM SUP2 plus lower energies H omega approximate equal 14 MeV plus narrow magnetic excitation plus scattering vector plus temperature dependencies plus intensity formation of an anisotropic local bound state in semiconducting MV materials plus average samarium valence is decreased by substituting La for SM. A peak is found to appear at high energies plus elastic magnetic form factor of SMB sub 6 plus polarized neutrons plus condensed para-hydrogen plus incoherent scattering function of liquid and solid para-hydrogen plus inelastic neutron scattering plus Tosca, time of flight inverse geometry, crystal analyzer spectrometer operating on the pulse neutron source at ISS UK plus intrinsic coherence plus scattering process, plus rotational transitions plus measured double differential cross section plus condensed hydrogen plus high energy region of the spectrum plus impulse plus center of mass motion applies plus extract translational mean kinetic energy low energy region plus Gaussian approximation and plus liquid phase. This goes on and on and on. This is all the keywords that came up with that video. Isospin dependence plus nuclear plus deformations plus 11 MeV neutrons plus elastically inelastically scattered plus 8 single cross shell nuclei plus 3 proton vibrational nuclei with n equals 50, and then those numbers there, plus 5 in neutron vibrational nuclei, and those numbers, with Z equals 50 plus. I promise the other videos are shorter. I didn't realize this one was so long. Electronic discrimination plus gamma rays plus TOF time of flight techniques plus measure plus energy plus scattered neutrons plus differential cross sections plus 0 degree neutron flux. We're going to add the optical mode OM analysis plus elastic data plus code GENOA plus potential parameters plus nucleus plus low-lying electric quadrupole 2 inches plus octupole 3 inches states plus low temperature phase lithium 7. The calculations plus 7 Li plus differential coherent elastic scattering cross section of thermal neutrons fixed plus the fixed scattering angle plus the energy of incident neutrons plus corresponding despacings plus sigma plus despacing plus atmospheric pressure plus 2 temperatures plus 80 plus 20K. We're going to add the calculations plus 80K plus BCC lithium plus 20K plus crystallographic structures plus polytype lithium, BCC, 9R, HCP, and FCC plus the time of flight 2F measurements of Berliner AL plus 80K lithium minus 7 plus martinsic transformation plus structural state plus 20K plus coexistence. So I had to Google martinsic transformation to remind myself what it means, and I'm going to do this search again in line 22 E10B. That's the next video, which we're not really looking at because we're looking at the Higgs stuff here, right? So dependence plus differential cross sections plus 100 to 150 MeV plus alpha particle plus elastic scattering plus 40 Ca plus nucleon plus density distribution in nucleus plus intermediate mass nuclei plus inhomogeneous target nucleus density plus anomalous growth plus differential cross section plus elastic scattering and plus average angles. We're going to add the low energy 4-body scattering system, add the neutron-neutron, the proton-proton, 2 nucleon scattering lengths, calculated neutron-triton scattering length plus triton plus binding energy plus analogous plus the Phillips line plus 3 nucleon. We'll take the triton binding energy, we're going to add the doublet nucleon deuterion scattering length plus calculated plus 3 nucleon zero range theory plus correction linear plus nuclear forces. We add the calculations plus the nucleon-nucleon potentials and add effective long-range interaction plus 3 nucleon system plus the correlation is reached. I'm going to Google 3 nucleon zero range theory and correlation June 25th, and again that's all going to line 22E10B. That's the end of that data. Oh goody, you know what? I started and then I cut out the rest and put it in different videos. Yay! So we're done that. Okay? Sorry that was so long. Thank you for watching.